Unit 11, Threaded Fasteners. Welding is a method of permanently joining materials together, but sometimes parts need to be assembled and then disassembled. A fastener is a device used to hold together parts that may be assembled and disassembled easily. Threaded fasteners such as bolts, nuts, machine screws, bosses, and studs hold parts together using threads. There are many advantages for using threaded fasteners. Because threaded fasteners are manufactured in standardized sizes in both English and metric units, they are easily purchased in large quantities from equipment distributors or a few at a time at a local hardware store. Threaded fasteners, unlike welding, can easily join dissimilar materials together, such as steel parts to aluminum or metal parts to plastic. Also, threaded fasteners are easily installed in a shop or in the field on the job site using hand or power tools. The threaded fasteners uses the principle of projecting an inclined plane around a cylinder shape for holding strength. The concept of the threaded fastener and many of the other simple machines is attributed to the ancient Greeks. The Roman legions used threaded fasteners to hold together armor, as did knights in the Middle Ages. However, there is no standard thread form. Each threaded fastener was made by hand, usually by filing the thread into the solid piece of a cylindrical material. Thread forms. In 1864, near the end of the Civil War, William Sellers described the need for a national screw thread standard at a meeting of machinists and engineers in Philadelphia. Sellers told the audience about the thread shape that could be manufactured easily and checked for accuracy using standard equipment found in a machine shop. This thread form remained the standard in the United States until Unified Thread Standard form was adopted in 1948. Unified Thread Standard form was also adopted by Canada and Great Britain. Metric-based threaded fasteners are classified under the metric screw thread series standard. The metric thread form is the world standard. For this reason, both inch-based fasteners and metric fasteners are used in the U.S. Inch-based and metric-based screw threads have the same basic profile or shape, but the two systems are not interchangeable. Common parts of the screw thread are shown in Figure 11.1. The basic shape of a screw thread is formed by a point curve that wraps around a cylinder in a spiral. This shape is known as a helix. The helix angle is the angle formed by the incline of the helix and the line perpendicular to the vertical axis of the screw thread. The pitch of the screw thread is defined as the distance from a point on one thread to the corresponding point on the next thread. For inch-based screw threads, the pitch is measured in relation to the number of threads per inch. It is expressed using the formula 1 divided by the number of threads per inch. For metric-based screw threads, the pitch is indicated as the actual pitch measurement and is measured in millimeters. Thread series. In the United States, or in the Unified Thread Symbol Standard System, threads are classified under thread series. Thread series are used to specify diameter, pitch, tolerance, and other standard characteristics. The most common threads found in the United States are classified under the Unified Graded Pitch Thread Series. Graded pitch threads are groups of diameters that change in pitch or the number of the threads per inch. There are three common graded pitch series: Unified National Coarse, UNC, Unified National Fine, UNF, and Unified National Extra Fine, UNEF. See Figure 11.2. Unified National Course threads are used for general purpose fasteners. The threads have common strength and are easy to fasten and unfasten. Unified National Fine threads have more threads per inch than coarse threads. They are used when vibration might affect the holding power of the threads. UNF fasteners are used for cars and airplanes. Fine threads are also used when the number of threads that can be engaged between the fastener and the mating part is limited. Unified National Extra Fine threads are used for instrumentation and application requiring fine adjustment. Constant pitch threads are also specified in thread series under the unified system and are used in some applications. In these series, the pitch remains constant as the diameter of the fastener changes. Common constant pitch series include 8, 12, 16, 20, 28, and 32 thread series. The series number designates threads per inch. Thread fit classes. Threaded fasteners are also classified by class of fit. The class of fit determines the allowability difference in size from the actual size or tolerance and the tightness or looseness between two mating fasteners. There are three classes of fit: Class 1, 2, and 3. Class 1 fits are used where the greatest amount of tolerance or looseness is allowed. Usually Class 1 fits are used for applications requiring frequent and rapid assembly and disassembly. Class 2 fits are considered the standard for general purpose manufacturing fasteners. Class 3 fits have very close tolerances. Class 3 fits are used to set screws, aircraft fasteners, and socket head cap screws. In threaded designations, external and internal threads are usually specified together with the class of fit. External threads are specified with the letter A, and internal threads are specified with the letter B. For example, Class 1A designations specify Class 1 external threads. Thread notes. A thread note is used to specify information for threads on a print. The note includes the nominal diameter of the thread, the number of threads per inch, the thread series, the class of fit, and the internal and external thread designation, and sometimes the length of the fastener. Figure 11.3 shows thread notes for both unified and metric thread forms. For internal threads, the tap drill size is often given with the thread note. A tap drill is a tool used to make a hole in a part for tapping or removing material to form threads. The tap drill is used to assure that approximately 75% of the thread depth is formed. If 100% of the thread depth is cut, binding and perhaps breaking of the tap may occur. Standardized tap drill sizes for unified threads are shown in Figure 11-2. If the tap drill diameter is not given with the thread note, the table can be used to determine the correct tap drill. To read the table, first determine the diameter of the fastener, then determine the thread form, for example, UNC or UNF. Finally, determine the threads per inch. The column next to the threads per inch column lists the correct drill tap. Standard thread representations. On prints, threads are typically represented using one of three methods. Threads are drawn using detailed schematic or simplified representations. Because of the time required to draw detailed representations, many companies prefer to draw threads in a schematic or simplified form. Methods of thread representation are shown in Figure 11.4. Detailed representation. A detailed representation shows the actual thread profile and accurate representation of the number of threads per inch. This method is very time-consuming and is not often used. Schematic representation. A schematic representation uses schematic symbols to represent the threads. It shows the thread crest lines with thin lines and the thread root lines with thick lines. Lines are often drawn at an approximation of the pitch rather than at a calculated pitch distance. The lines are drawn perpendicular to the major axis of the fasteners. Simplified representation. A simplified representation is the most common method for representing threads on a print because it is easy to draw. For external threads, the crest line is shown as an object line and a root line is shown as a hidden line. For internal threads, the crest line is usually shown as a hidden line. However, other representations may be used depending on the type of drawing. Metric threads. The method for showing metric threads on a print is similar to that used for the unified threads with minor variations. All metric threads notes start with the letter M followed by the diameter. The pitch is then shown in the note following an X. For example, 10 millimeter thread with a 1.5 millimeter pitch would be shown as 10 M10 by 1.5. Types of fasteners. There are many types of threaded fasteners. The major types include bolts, nuts, and screws. Variations of each type are used for specific applications. Bolts are used to assemble parts not requiring close tolerances. They are manufactured with hexagon or square heads. Nuts are used to secure bolts into assemblies. Screws are used to fasten parts and hold assemblies in place. Common types include cap screws, machine screws, and set screws. Cap screws pass through a clearance hole in one part of their screw. One part are screwed into the threaded hole in the mating part. Machine screws are smaller diameter fasteners and are usually used for thin parts. Set screws are used to prevent rotary motion between two parts or to hold a part in a specific location. In some applications, fasteners are welded to parts. Bolts, nuts, or screws are sometimes joined by welding because welding makes the fasteners easy to attach. Common threaded fasteners that are welded include the weld nut, stud, and boss. Fasteners may be attached by arc welding or resistance welding. Joints may be made with weld nuts. Studs are usually considered projection welds. A weld nut is used on thin sections where there would not be enough threads engaged in the material to provide adequate holding strength. A stud is used when the external thread is required. A boss has internal threads and is used for locating a mate part in an assembly.